Now in the previous video we have seen how we can create signals like impulse, ramp, and at the end we have seen also one signal called a step. So we have in total we have created three signals: impulse, a step, and ramp. Now in this video we are going to create exponential signals. We will create exponential signals. To create exponential signals we should know two functions. One is exp. Exp is the function in MATLAB which creates or which returns exponential value when we give any value to it. Suppose we write 5 here, then it will return as e to the power 5. So this is the exponential. Besides for creating exponential signals for base other than e, we can use the function like this. Suppose we want to create 3 to the power 5, so we can write 3 caret sign 5, it will create 3 to the power 5. So we will do these things in MATLAB today. So before going to the MATLAB, we are first of all we will write our code here and we will see how it runs basically. So suppose we write one code. We already have the value of n from the previous program, like n equal to minus 5 to 5. After n, suppose we define a variable, simple integer variable which is given the value x 4. Now after this we will write a dot caret sign 4. What does this mean? Now what does it mean? Since we know not here 4, actually we will have to write here n. We know that n is a vector. What is the length of vector? It is 11 point vector. What are that points? Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. These are the 11 point vector. The name of this vector is n. So n is a 11 point vector. Now we appended a to the power this vector, a to the power this vector, and all the variable will be contained in the new variable named x. So x is a vector having the value 8 to the power n. So a value of a is what? 4. So 4 to the power 5, 4 to the power minus 4, 4 to the power minus 3, 4 to the power minus 2, and similarly up to 4 to the power 5. So this is the exponential signal we have created here. This is our exponential signal, and now we will plot this with respect to n. How it will look like? It's simple. It will look like this. It will look like this since it is a pointer. So it will go like this. Nothing wrong in this. It will cross all the lines. Means it is going to increase like in an exponential manner. So that's why we have written here a equal to 4. By changing the values of a, we can see how different things will happen. So first of all we will create the program and then we will analyze when we will change different values of a, we are going to get different types of signals. We will see that. But before going to the code, we must remember here we have taken a equal to 4. Now before we have used exponential. Exponential means e to the power something. E is also greater than 1 and 4 is also greater than 1. So both will have the same property. In short, we define a of type 4. Suppose a equal to 8 dot or a to the power n, then we can have 4 types of a. A can be, suppose we write here 0, 1 and here minus 1. If a is from 1 to infinity, it is type 1. If it is 0 to 1, it is type 2. If it is minus 1 to 0, it is type 3, and this is type 4. So there are 4 types of values which are possible for a. And now we have seen e and 4. They both lie in the first region. After that we will see different values of a. We will also use these regions also with one example. But before doing these things, we will write the program and then we will come back. So let's go to the MATLAB and write. here we have the previous code. I can run it and we can see the output. What it is saying? Oh, it is saying we have to add the path in this folder. So we will cancel it and we will go to the our inside directory. It is saying to open the directory which we have created, digital signal processing, to be the current folder, otherwise it can't see the file. So we are inside the folder and now we will run it and we can see it can run. So it is coming. Now just we have to write the code here. So let's start writing the code for the exponential signal. So I will write here exponential signal, and then I will write here x equal to, first I will use the exp. We know we know the type of graph which we will get from here, but for simplicity we have just written it. And now after writing the exponential, I have to just plot. I have get the value of x, so I will just copy and paste all the things here. So let's paste it. What I have to change? We have to use the fourth section. So I have just written here, and unit exponential. Unit not, we have to write here exponential only. Exponential with e, I can write it with e, and I will just run it and we will see the output. So we can see here it is the output. It is going from 0 to 150. At the end our value is 150 here. So minus 5 to 5 we are going, and it is approximately 150. I have to just here, I should make this, otherwise that's why it is coming the error again and again. So we have to suppress the output so that it not need to be appear in the command window. So I have suppressed it. So I can again run it and see it. There will be nothing different. So again it has been run. I will clear the command window. So now we can see we have just created our exponential signal with exp. Now after that we will create the signals with different values of a. We will now use different values of a to create our signals. First we will create a greater than 1, then we will create a less than 1 but it will be greater than 0, then minus 1 to 0, and at the end we will take the value of a which is less than what? Minus 1. Okay. So now let's again start plotting the graph. So first of all we will use a equal to 4. I create a variable here, a equal to 4, and after that I have to write x equal to a dot. We have to use the power, n, and after that I have to just copy and paste the plot where we have to create all the things. Okay. So I have just pasted it. So here we have the exponential and with a greater than, or I will not write it with exponential, I will write the range of a. What is the range of a? It is greater than 1 to 1 say a, and less than, I will write inf, infinity. Okay. So I have changed the title to make it little smaller. So it is a expo, expo means exponential, and the value of a is ranging from 1 to infinity. We can take any values of a which lies between 1 to infinity, and we have to change the subplot also. So I will write here 5. So we are now know that the both signals which we have created above and below, both will be in similar fashion. There will be no much different in this. So as we will run the program we will see it. So let's check it. Now as we can see it is similar, as like it is rising in nature with the values of n. In the similar way it is also rising in nature with the values of n, actually not a, with the values of, as the values of n is going to increase, the value of function is also increasing. Similarly here also. Now after this we have to change only the value of a, so we have to do nothing but just paste it again and change the value of a. So let's come down and we will paste here, and now we have to, what we have to do, we have to change the value of a, and now a will lie between 0 to 1. So we will take 0.5, for example 0.5. we will change the subplot, we have to consider the sixth section, and now we have to change the value of a here. So a is ranging from 0 to 1, so infinity will be replaced by 1. Now I can run the code again and we can see now there will be change. Before 2 were increasing, but now it will be decreasing. Okay, I think it has not run. It should run. Any problem with it? Let's check it. Why it is not showing the answer? A is 0.5 and we are replacing the values of n. We should get actually, but what is the issue? So there is nothing problem, then it only took some time to appear, so it took some time for its calculation. There is nothing any error. So now we can see the signals here with E and with A, both were increasing in nature, but here we can say it is decreasing in nature. Now we will change the value of A also and we will see the more magic now. So let's change it and write here A will go to minus 0.5, okay, minus 0.5, and it will be now in the 7th section, and this will change to minus 1 to 0, minus 1 to 0. This is our next, and now we will run it and we will see it, the plot. So we can see now the plot is like this, up and down, okay, and after that we will see the last, when A is ranging from minus infinity to minus 1. For that we will take the example of minus, we can take minus 2. It will be our 8th plot, and here we have to write minus INF, minus infinity to minus 1, and I will run it. So here we can see. So we have now got all our 8 figures here. All our 8 figures are present here. Now we have to just discuss the 2, or we can see 3. These 3 figures we have to discuss. We have already discussed this one, figure number 5 and 4. So we have just need to discuss figure number 6, 7 and 8. So let's move to the board and we will see how when we change the value of A, why it changes like this. So let's come to the board. Now suppose we change the value of A here. It was A equal to 4, and now suppose we have A equal to 0.5, okay. Now since it is ranging from greater than 0 A but less than 1, and at this we take the value of n. So what will happen? Since it is 1 by 2 to the power n, so as value of n increases towards plus infinity, it will be like 2 to the power 2, 2 to the power 4, 2 to the power 5. That's why it is decreasing in positive side. But in negative side, 1 by 2 to the power minus 2, 1 by 2 to the power minus 4, 1 by 2 to the power minus 3, it will return 2 to the power 3, 2 to the power 4, 2 to the power 2. Means in left side it is increasing, but in right side it is going to 0. So that's why the graph of this signal is coming like this. okay, coming like this, and it is at the end it is going to 0. In left side it is increasing, while in right side it is decreasing. This was the case with 0 a equal to 0.5. Now we can also verify it again in the MATLAB itself. We can see here when a is ranging from 0 to 1, it is going like decreasing very fast, it is decreasing. After that we will take a equal to, we will take a equal to minus 0.5. It is ranging from minus 1 to 0. What is the case with this? It is minus 0.5. When we will have even power of this, it will be positive. For if we write minus 0.5 to the power n, if n is even, if n is even, then what will be? If n is even for positive, I am saying for positive, if it is even, then it will be positive, and if it is odd, then it will be negative. So what will it will look like? If we consider the graph with positive value of 0.5, we have seen it. It was like this. It was like this. It was like this. So it is the same graph, but it will be now fluctuating. If we have the positive value of n, then it will be up, and if it will be negative values of n, then it will be down. So it will go like this, still decreasing, but go like this, means it is fluctuating up down, it is fluctuating. And in the similar fashion here also, suppose we take the minus 0.5 to the power minus 2, what will be the answer of this? First of all, it is minus 2, so it will go minus 0.5 to the power 2. Now in the denominator we have to write 1 by 2 to the power 2, okay. So it will again go 2 to the power 2 upside. Since the power is even, and so this negative will be cancelled, and we will get 2 to the power 2, that is 4. So it will be like here, suppose it is here minus 2, then the value is going to be 4, okay, for the minus 0.5 case. So this is the graph of the signal with a equal to minus 0.5. We can see it here also. This is the case. It is going down like this. It is decreasing, but by fluctuating also. It is decreasing as well as fluctuating. We can increase the values, but we can see here it is like that. And in the similar fashion, this is the opposite of this, a greater than 1. So again it is being fluctuating up and down. It is fluctuating, we can see here it is fluctuating in the similar fashion. So in this way we have discussed all the graphs. So this is the end of the video. I hope you got well.